So it's now my distinct pleasure to introduce today's commencement speaker, our own Dr. Thomas Geisbert. Dr. Geisbert is professor in our Department of Microbiology and Immunology and a scientist in our Galveston National Laboratory. He is one of the world's leading Ebola experts and has nearly 3 decades of experience working with the deadliest infectious agents. He received his PhD in molecular pathobiology from the Uniformed Services University of Health Sciences in Bethesda. From 1985 to 2007, Dr. Geisbert served in various roles for the U.S. Army Medical Research Institute of Infectious Diseases at Fort Detrick, including serving as chief of their Department of Viral Pathology and Ultrastructure. He joined UTMB in 2010 from Boston University, where he had served as associate director of the National Emerging Infectious Diseases Laboratories Institute and professor in their departments of microbiology and medicine. He co-discovered the Reston species of Ebola virus in 1989, which garnered national attention and was featured in Richard Preston's best-selling novel, The Hot Zone. His numerous awards include 2 Department of the Army Commander's Awards for civilian service, one for his work to identify the Ebola Reston virus, and the second for his support of the operation known as Noble Eagle. This is a name that was given to military operations related to Homeland Security and support to federal, state, and local agencies in the wake of September 11th. He recently received an honorary doctorate in humane sciences from Hood College for his outstanding research contributions. Class of 2016, ladies and gentlemen, please join me in welcoming Dr. Geisbert.
Thank you, Dr. Callender, Dean Jacobs, Dr. Raymer, UTMB faculty, and the graduating medical students of UTMB. I've been very fortunate to receive a number of awards in my career, but I think the greatest honor that you can ever receive in my profession is to be invited to speak by the students. So I especially want to thank the medical students. It's hard to believe it's been 6 years since I've been here in Galveston. I know that for many of you, this is a time of transition as you leave the world of formal education and you advance your medical career. I'm going to walk you through my story, my career path, and tell you a little bit about what I've learned that hopefully made me a better and more productive person. I'm going to emphasize 3 areas this morning. 1, don't be afraid to step out of your comfort zone and make the most of every opportunity that you get. 2, perseverance. Never give up. Never ever give up. And 3, one person can make a difference and change the world for the better. I'm going to tell you a little bit about my background. I was born and raised in an area where Maryland, Virginia, and West Virginia all come together, very unlike Texas, where you can drive all day and be in the same state. I was in 3 states every day. No offense to any of the Astros or Rangers fans here, but I was and still am a huge fan of the Baltimore Orioles. When I was growing up, when I was a little kid, I wanted to be a professional baseball player, something I was pretty good at early in life, until I got a little older and I went to college in a D3 school and realized that I stunk. And biology and chemistry were always my best subjects when I was in school. It came the easiest to me, didn't have to study as much for those. So after I graduated from Western Maryland College with a bachelor's degree in biology, I really didn't know what I wanted to do for a career. I knew that running projectors at a local movie theater was not my calling in life. After a few months of not really knowing what I wanted to do and procrastination, my dad confronted me one day and put his arm around me and said, son, it's time to get a job. You're not going to be failure to launch. My dad was actually a building engineer at the U.S. Army Medical Research Institute of Infectious Diseases in Fort Detrick, Maryland, and that's really how I ended up getting a position there in the electron microscopy laboratory in the pathology division. If you're not familiar with electron microscopy, an electron microscope uses a beam of electrons to create an image of a specimen. So where a conventional light microscope can magnify a specimen maybe 10 to 40 times, An electron microscope can magnify a specimen 100,000 times or more. So you can see a virus particle with an electron microscope. At USAMRIID, at the time, it was used as a tool for assisting in the identification of viruses, diagnosing infections, and in studying disease pathogenesis. So this opportunity led me to pursue a master's degree, which opened even more doors for me. Upon completion of my master's, I accepted a position to work with Drs. C.J. Peters and Peter Jarling in the Disease Assessment Division at USAMRIID. These were the guys that worked in biosafety level 4 on the most dangerous viruses known to man. I had never planned on working in this particular area, and I admit it was a little scary at first. But this leads me into the first theme of my talk, which is don't be afraid to step out of your comfort zone and make the most of every opportunity that comes your way. As many of you know, Ebola virus causes severe hemorrhagic fever in humans and also in non-human primates, and kills up to 90% of the people that infects. To work with Ebola, you have to work in a positive pressure suit, or what we call a space suit. So if any of you remember the movie E.T., the blue suit, the blue plastic suit that they wore, believe it or not, we have that pretty much same suit in the Galveston National Lab, and that's pretty much still what we wear today. It takes about 3 to 4 times as long to do anything when you work in a spacesuit. So back in 1989, when I was at USAMRIID, we were working on a virus called simian hemorrhagic fever virus that I'll call SHF. And we were using this as a surrogate or a model for Ebola and other BSL-4 viruses. Now, SHF causes a lethal infection in monkeys that's very similar to what Ebola causes in humans. But unlike Ebola, it does not cause disease in man. So the advantage is that we could work with SHF at a lower level of biocontainment to make research go faster, and then hopefully to be able to apply these principles that we learned to Ebola. Now, Peter Jarling, who was my mentor at the time, was giving a talk in the southeastern United States on some of the work that we had done with SHF virus. There happened to be a veterinarian in the audience that day who worked at a primate holding facility in Reston, Virginia, which was not far from USAMRIID and was a stone's throw from the nation's capital in Washington, D.C. A few months after hearing Peter talk, the veterinarian noticed that the monkeys in his facility that had recently been imported from the Philippines were dying from a disease that fairly closely resembled SHF. So he called Peter and asked if we could confirm that the agent causing the death in his monkey colony was in fact SHF. So I'll never forget the day when the samples showed up in a styrofoam box from Reston. Again, this is 30 miles from USAMRIID. We actually unpacked that box in Peter's office that contained tissues wrapped in aluminum foil. And the tissues were dripping. There was blood dripping from the tissues into the bottom of the styrofoam box. So we went into one of our one of our labs that was actually not a BL4 lab, and we attempted to culture the virus from the samples to confirm that it was indeed SHF. So we did this work in a lower level of containment where we did not have spacesuits on. A few days later, we started to see evidence that the cultured cells that we had employed to isolate the virus were dying, indicating that an infectious agent was present. So Peter came into the lab to look at the cultures and thought that the cultures may be contaminated with bacteria. So he performed what we called an old school sniff test, where he removed the cap from the flask and sniffed the flask to see if it smelled like grape juice, and which would be a telltale sign of bacterial contamination. He then handed me the flask and asked me to do the same. Probably not the smartest thing that I've ever done in my life. Long story short, I applied my newly learned skills in electron microscopy to analyze the cells and see if I could detect a small spherical virus that would be consistent with the morphology of SHF virus. Instead, I did not see SHF virus. I saw these long, filamentous, spaghetti-like particles that turned out to be a new species of Ebola virus. So fortunately, I survived sniffing Ebola. A few years later, Richard Preston turned this story into a best-selling novel, as Dean Jacobs noted, called The Hot Zone, which was #1 on the New York Times best-selling list for several months in the mid-1990s. And Richard became a millionaire many times over And because I was a U.S. government employee, all I got was an autographed copy of the Hot Zone and a Christmas card every year. I think that Peter and I would both say to you that sniffing that flask of Ebola was the second dumbest thing that we ever did. Telling Richard was the dumbest. But this discovery at that time in my life, when I was young in my career, like you guys are here today, this was really the break that I needed as a young scientist, and it gave me a goal. It increased my enthusiasm and my passion for scientists, and it really pushed me to finish my PhD. So I was obsessed at that time with finding a cure for Ebola. I wanted to do something that no one else had ever done. To this day, I still have that same enthusiasm that I had many years ago. And I've learned through the process of selecting PhD students for my own laboratory that it's not always the student with the highest GRE score or the highest GPA that ends up being the most successful. It's the student with the most enthusiasm. So I can teach a student virology, but I can't teach enthusiasm. So no matter what career path you go down in your medical profession, it's important to choose a path that you're passionate about, something that you really love. The second theme that I want to talk about today is perseverance. So I spent a lot of time during the decade of the 1990s trying to develop vaccines and treatments against Ebola, and it was very frustrating. We managed to develop a number of medical countermeasures that were able to completely protect mice or guinea pigs against Ebola. So we'd get really excited. We'd develop a new vaccine or a new treatment, and we'd go in and we'd test it in rodents, and they'd all be protected, and you'd be on cloud 9. And then we'd try that same treatment in monkeys, and monkeys are, of course, the gold standard model. The disease in monkeys is very similar, and it's pretty much exactly the same as man. And it'd be very frustrating because the monkeys would all die. And so it was a decade of failed study after failed study after failed study. And that was really, really trying on me. And then there were the naysayers. There were people that would ask, why are you working on a disease that globally really doesn't affect that many people? And certainly doesn't impact the lives of Americans because, as you know, Ebola is a disease that mostly affects Africa. So now we know that the former Soviet Union had been developing Ebola as a bioweapon during the Cold War, which is why we were working with it at USAMRIID. But after 9/11, the US government became even more concerned about Ebola as an agent that could be exploited by terrorists. So more funds were put into research. Now, one of the things that you learn from failure is what doesn't work, and by the process of elimination, what not to do. So my failures in the 1990s led to many successes in the decade of the 2000s. With some very close colleagues, we were able to develop both preventive vaccines and a post-exposure treatment that completely protected monkeys against Ebola. So again, I was very excited about these breakthroughs until reality sank in. So before the year 2014, there was a very small global market for an Ebola vaccine or treatment because outbreaks occurred sporadically and affected small numbers of people in remote areas of Africa. So there was no financial incentive for a big pharmaceutical company to produce an Ebola vaccine or drug. So this was not like you had a drug that could cure cancer or prevent heart disease, or even maybe a vaccine against something that's more prevalent like influenza. So we had developed all these vaccines, and particularly one that I'll talk about here in a minute. We were really excited about them, but there was no market for them. Nobody wanted to move them forward. So as many of you know, there was a recent large outbreak from 2014 and just recently ended with over 30,000 cases, or nearly 30,000 cases of Ebola that started in West Africa, in the country of Guinea, and it spread like wildfire early in 2014. And of course, by the summer of 2014, the outbreak was out of control, but it really wasn't until the Americans were involved that much attention was given to it here in the US. And I remember watching TV late in July in 2014, and I don't care which major network you were watching. I don't care whether it was CNN or Fox News, or I'm a sports nut, so I was watching ESPN, and they actually broke in with coverage of the American worker Kent Brantley, who was a healthcare worker who was infected with Ebola, and he was evacuated from West Africa and repatriated to the United States. And And we watched this event unfold on TV, from the landing of the private jet in Atlanta to the ambulance driving through the streets of Atlanta to Emory University Hospital. And then a few days later, we had watched it play out again with his colleague, Nancy Wrightball, going to Atlanta, and then Rick Saker going to Nebraska. And for a while, I'm watching TV and they keep breaking in with this news coverage, and I thought we were watching O.J. Simpson and the white Bronco go down the LA freeway. So it got the Americans, it got our attention here as Americans. And a few weeks later, it really hit close to home for us here in Texas, when a man arrived from West Africa on a plane in Dallas, Texas, and infected two of his attending nurses in the Dallas hospital. And it's unfortunate, but it was this involvement of Americans that brought attention to the Ebola problem. It made us realize that what happens in a remote place can indeed impact our lives here. So it's good that the recent outbreak has finally been declared over. I think if there is a silver lining in this outbreak, it's the fact that the media attention got the public engaged. When the public got engaged, politicians took notice, and all of a sudden, a lot of red tape was cut. And there was a push to fast track some of the leading medical countermeasures. And one of the vaccines in particular that I was involved in developing. The final theme that I want to address is this: one person can make a difference, and one person does matter. And when Time Magazine interviewed me in 2014, we were talking about both one of the drugs that we developed called TKM Ebola, and then one of the vaccines that we developed that you may know is the Newlink Merck VSV vaccine. The reporter Alice Park asked me, "So Tom, why do you do this? Why do you work with something that can easily kill you, and what motivates you?" And my response was that I'm in the medical field. I want to help people. I've traveled the world, and especially seeing firsthand the poverty in third world countries, I really realized how fortunate I was to be born an American. Last year, the World Health Organization conducted a ring vaccination cluster randomized trial in Guinea using our VSV Ebola vaccine. There were over 4,100 people in a group of contacts of Ebola patients that were randomly assigned to receive immediate vaccination with our Ebola vaccine, and over 3,500 that were randomly assigned to delayed vaccination with the same vaccine. In the immediate vaccination group, there were no cases of Ebola with symptom onset at least 10 days after randomization, whereas in the delayed group, there were 16 cases of Ebola. Now, I'm not a statistician, but the paper that described this trial just came out in The Lancet, and the interim results do show that the vaccine was highly protective, or suggested it was. The vaccine is continuing to be used in West Africa, and the data are continuing to be assessed. Now, I'm not going to stand here today and tell you that I know for an absolute 100% certain fact that that vaccine saved all of these people. But my response to the Time reporter was that if our vaccine saved the life of just one person, then it was all worth it. This leads me to one final thought. I was at the University of Texas in Austin last year with Dr. Callender to participate in the annual Chancellor's Council meeting. The Chancellor of UT System is a man named William Bill McCraven. Some of you may know him. He's a Navy SEAL and a retired U.S. Navy Admiral who last served as the 9th Commander of the U.S. Special Operations Command. He's the most dynamic speaker I've ever seen, certainly among the best. And the gentleman who introduced him that day made reference to a commencement speech that Chancellor McCraven gave at the University of Texas in 2014. So this is the beauty of a Google search in YouTube. Knowing that I would be speaking to you today and looking for ideas, I looked at that speech, and I'm going to borrow a few things from it, giving all due credit to Chancellor McCraven. So he begins that speech by saying, "Tonight there are almost 8,000 students graduating from UT. That great paragon of analytical rigor, Ask.com, says that the average American will meet 10,000 people in their lifetime. That's a lot of folks. But if every one of you changed the lives of just 10 people, and each one of those folks changed the lives of another 10 people, just 10, then in 5 generations, 125 years, the class of 2014 will have changed the lives of 800 million people." 800 million people, think about that. Over twice the population of the United States. Go one more generation and you can change the entire population of the world, 8 billion people. If you think it's hard to change the lives of 10 people, change their lives forever, you're wrong. I saw it happen every day in Iraq and Afghanistan. A young army officer makes a decision to go left instead of right down a road in Baghdad, and the 10 soldiers in his squad are saved from his close-in ambush. In Kandahar province, Afghanistan, a non-commissioned officer from the female engagement team senses something isn't right and directs the infantry platoon away from a 500-pound IED, saving the lives of a dozen soldiers. But if you think about it, not only were the soldiers saved by the decisions of one person, but their children yet unborn were also saved, and their children's children were saved. Generations were saved by one decision, by one person. And this small part of a speech by Chancellor McCraven really clicks for me and puts what I do into perspective. If my work can save one person from Ebola, then it matters. Changing the world can happen anywhere and anyone can do it. So what starts here at UTMB can indeed change the world. But the question is, what will the world look like after you change it? In closing, I would like to congratulate each of you. You're moments away from beginning the next chapter of your life. While I told you about my story, I did not tell you about all the people that helped me along the way. Seek out good people to help you through life. One of my mentors told me many years ago, and I'll never forget this, don't be afraid to surround yourself with people that are smarter than you. They will make you better. I will also never forget something that my father taught me as a very young child when I didn't get my way, and that was quite often. He said, Tom, life is not fair. There will be failures and there will be setbacks. You need to take risks. Most things in life that are worth having don't come without risk. Step up to the plate when the times are tough. Lift up those less fortunate than you, and never, ever give up. What you have started here will indeed make the world a better place. Thank you very much for the honor of speaking today, and congratulations.
Thank you very much, Dr. Geisbert. In recognition of your outstanding accomplishments and your great speech today, we want to present you with this medallion.
Oh, thank you very much.
Yeah, thank you.
Thank you.
Congratulations. Thank you.